Okay, let's dive right into this explainer. When you think of Ireland, I bet you picture, rolling green hills and, well, rain, right? But man, this summer, the data is telling a completely different story. We're going to take a really rapid, data-driven look at exactly why Ireland is absolutely sweltering right now. We'll explore the atmospheric dynamics, the geography, and even local architecture to figure out what is driving this sudden, intense shift in our weather reality.
What's really fascinating here is the year-over-year contrast. I mean, it is stark. Just last year, back in July 2025, atmosphere conditions gave us a pretty moderate summer, comfortable enough that a light jacket was standard evening wear. Fast forward just 12 months to July 2026, and it's a complete 180. We're dealing with rare heatwave conditions, intense sunshine, and people literally buying up every fan they can find. So you might be wondering, what on earth shifted in the atmosphere to escalate things from a mild summer to this sun-drenched extreme so quickly?
But the main culprit is the meteorology happening right above us. It's a high-pressure blocking system. Think of it like a massive, invisible wall just parked over us, extending all the way from Western Europe straight into Ireland. Normally, we'd have Atlantic weather systems sweeping through, bringing our standard clouds and rain. But this persistent high-pressure block? It acts like a giant shield. It completely wipes out the cloud cover and functions like this huge atmospheric pump, just dragging unusually hot, super dry continental air straight northward, into regions that, honestly, almost never see it.
And the result of that massive atmospheric block? A staggering 30 degrees Celsius. With all that persistent dry air and literally zero cloud cover to block the sun, local thermometers are just rocketing up toward 28 to 30 degrees in a bunch of places across the country. Now, for a regional climate that is biologically and geographically hardwired for mild, wet summers, hitting those numbers is a severe and deeply felt shock to the system. We're talking about sustained, intense heat that the local ecosystem is simply not used to processing.
Okay, let's bring this down from the atmosphere and connect that macro weather data to the actual human experience, specifically our homes. See, Irish houses were historically engineered to do one specific job really, really well: trap and retain heat to survive damp, chilly winters. They're essentially giant architectural thermal flasks, and because of that, they completely lack any built-in cooling infrastructure. The result? During a rare thermal anomaly like this, the heat is actually magnified indoors because the houses are doing exactly what they were built to do. So the only immediate defense people have is a massive surge in electric fan usage, just trying to force air around to make these spaces somewhat livable.
So, zooming out a bit, Ireland now finds itself squarely trapped within a much broader Western European temperature anomaly. It's not just that 2026 is warmer globally. It's this specific, stubborn atmospheric dome colliding with our local environment, basically turning our heat-retaining homes into really uncomfortable traps. It's this fascinating, albeit super sweaty, collision of natural meteorology and human engineering. So I'm going to leave you with this final thought. As these rare heat waves start becoming our new data points, how quickly will we need to completely rethink and retrofit our architecture just to survive the summers of the future?